Hi everyone. Let's start with classification. Classification overview. This is an important part of machine learning. So, as you know, machine learning teaches computers to do what a human can do naturally. So, that's mostly learn from experience. So, there are some algorithms that use the computational methods to learn information directly from data without relying on a predetermined equation as a model. So I'm going to take you to the categorization of the machine learning. So machine learning uses two types of techniques, that is called supervised learning. Another one is unsupervised learning. Supervised learning trains a model on known input and output data so that it can predict future outputs. And in case of unsupervised learning, it finds the hidden patterns or intrinsic structures in the input data. The aim of supervised machine learning is to build a model that makes predictions by taking a known set of inputs and outputs and trains a model to generate reasonable predictions for response to new data. For this purpose, the supervised machine learning uses classification and regression techniques to develop predictive models. Here in our course, we will be mostly emphasizing on the classification techniques to develop the predictive models. In the classification techniques, predict categorical responses, for example, whether an email is genuine or spam, or whether a tumor is cancerous or benign. Classification models classify input data into categories. Typical applications include medical imaging, image and speech recognition, and credit scoring. Whereas the regression techniques predict continuous responses, for example, changes in temperature or fluctuations in power demand. Some of the examples. And typical applications may include electricity load forecasting and algorithmic trading. Besides the classification regression, the unsupervised learning mostly uses clustering. So here is one example of the clustering example. So trying to predict a graph, drift and with income along both of the x and y axis, and three different clusters are going to be predicted, and how they are going to be predicted and what are we going to learn from this clustering. You could find this from this link that I have provided here, and you will have more idea regarding the clustering technique for unsupervised learning. Let's first see what is the basis of classification model. So major technique for classification model is to, or the major objective is to identify the class of an individual based on observed features or attributes or characteristics. So while training a classifier, training data set is used to determine the mapping function, that is f of x with x, the features as inputs. In turn, it returns the output c of the classes. So where the set of classes are C1, C2 up to Cm, and features are from X1, X2, X3 up to Xk. So the general procedure is for training the data set with the mapping function, and after training, the validation technique is performed. So here what is done basically, here we accuracy of the classifier is measured by applying it to a test dataset that is separate to training dataset with known classes. This is the basis of classification method. So let's see one of the classification most famous classification method called K-nearest neighbors in the next slide, or it's also called KNN classifier. So if you see in this graph, in this visualization, um, the graph is plotted against petal width in the y-axis and petal length in the x-axis. And for a test observation A, we are supposed to find a distance between A and every other observation in the feature space. And then we are supposed to classify the test observation based on the votes of the nearest neighbors. So what it says here or explains, that is, if you see there is a node, these are set of nodes, different classifications or clusters of nodes in different color. So if you see there is a question mark, so here the node with the question mark is considered as a test observation A. Let's consider it as a test observation A. Distance is found from A and every other observation nodes in the space. The nodes that are closest to the node A, that is question mark, for them the k value as distances is found. First we are done, we have to do the or measure the distances, and once they are found, based on that smallest distance classification is performed. And A is classified as Setosa species. So here there are three species: Setosa, versicolor, virginica. But to be sure about which cluster define or predict as which type of species, we need to use the k-nearest neighbors classification method. So let's see how it is being classified. So the closest k values are to be classified as the Setosa species. Then the next species is to be classified as the virginica with the red color, and then last one, the green color. The red color is the versicolor and the green color is the virginica. So this is how uh, the classification is done. Now the next classification method is decision trees, DT. So here what are we supposed to do? First step, first create a node by splitting the data according to the feature that splits the data mostly, and repeat on data subset until a stopping criterion is met. And each leaf will correspond to a class. So we need to set a base, that is, let's take the x-axis value petal length which is less than 2.45, and in the next we will see we will assume a value for petal width which is less than 1.75. Okay, from this, here what we can do to determine which type of species actually points to which type, that is whether it's Setosa, virginica or versicolor, we need to follow the decision tree technique. So first thing, we consider the petal length if it's less than 2.45. Okay, so if it's true, then Setosa will be predicted. If the petal length is not less than 2.45, if it's false, then first it will see whether the petal width is less than 1.75. If it's true, go and see if petal length is less than 4.95. If it's true again, then the versicolor species is identified, else virginica will be identified. But let's say the petal width is not less than 1.75, then petal length 4.95, whether it's less than this value or not, is checked. If it's true, virginica will be classified. If not, then um, virginica will be classified too. So this is the decision tree technique, and this technique is mostly known for overfitting the data. So what is overfitting, underfitting? The cause of the poor performance of a model in machine learning is either overfitting or underfitting the data. So what does it mean actually? Overfitting means your model may overfit to your data set that is used for training and testing and can give you high accuracy, but it doesn't have a good outcome for the other dataset. So decision trees are also known to provide higher accuracy and in turn lead to overfitting problem. Whereas the underfitting occurs when machine learning algorithm cannot capture underlying trend of data and when model or algorithm doesn't fit the data well enough. So these are some basic characteristics of the decision trees. Next technique is our Nav bias or NB classification method. So Nav bias, what it does actually, um, here the Nav bias is a classification technique based on bias theorem. There is a theorem with an assumption of independence among predictors. So in simpler term, this classifier assumes that the presence of particular feature in a class is unrelated to the presence of any other feature. So let's take an example. Suppose you have a fruit which may be considered to be an apple if it is red, round, and about 3 inches in diameter. Even if these features depend on each other and upon the existence of other features, all of these properties independently contribute to the probability that this fruit is an apple, and that is why it is known as Nav. So, Nav bias is based on this theorem. So, if you see the first equation here, so it provides the basic theorem actually provides a way for calculating the PCX, that is the posterior probability from PC, PX, and PXC. So what are these again? So PCX is actually posterior probability, PXC is your likelihood, and only simple PC is our class prior probability, and PX is the predictor prior probability. So we will go into the detail about this algorithm later, this classification method, but this is just the base of the Neb bias algorithm. Now let's move on to the next type of classification method, which is called the support vector machine. So support vector machine is a supervised machine learning algorithm used for both classification as well as regression challenges. So, however, it is mostly used in classification problems. In the SPM, we plot each data item as a point in the n-dimensional space. Here you see the picture that is shown. And here n is the number of features that you have, with the value of each feature being the value of particular coordinate. Then we perform classification by finding the hyperplane that differentiates the two classes very well. So here there are two classes, two classifications, and based on the hyperplane, the lines, you are going to classify them properly. So support vectors are simply the coordinates of individual observation. SPM classifier is a frontier which best segregates the two classes. Actually, the first thing is that um, this is the basic support vector machine method. So first thing is to identify the right hyperplane, that is the scenario one. So either you take this hyperplane, there are four lines, which hyperplane you need to consider. Then you need to identify the hyperplane in scenario 2. So let's say you have four hyperplanes and all are segregating the classes well. Then how can you identify the right hyperplane? And after doing that, in the scenario 3 also you need to identify the right hyperplane based on some set of rules. And like this, you will segregate all the classes. Here actually you have two classes. If you have more than two classes, multiple classes, you need to segregate based on the hyperplane. And then you do the classification. So this is all about your classification algorithm.